In this presentation, I will discuss the functions, food sources, and metabolism of vitamin A. Be sure to have your textbook opened and the presentation slide handout printed, ready for note-taking. Collectively, the three forms of vitamin A are referred to as the retinoids. In this graphic, please note that retinol and retinal can be converted to each other. But once retinal is converted to retinoic acid, there is no going back. Retinol is the form of vitamin A that circulates in the blood, while retinal is the form that is important for vision. Retinoic acid is the form that affects gene expression and cell differentiation, growth, and reproduction. The carotenoids, which includes beta-carotene, serve as antioxidants. Because vitamin A is fat-soluble, it is lost when milk fat is removed or skimmed off of the top of the milk. Therefore, reduced fat, low fat, and fat-free milks are often fortified with vitamin A. Margarine is usually fortified with beta-carotene to the same level as butter. This fortification not only adds a vitamin A source, but also provides the yellow coloring of margarine. The bioavailability of carotenoids varies from the level of fat in the meal. The more fat in the meal, the greater the bioavailability, with carotenoids being less bioavailable than preformed vitamin A. As vitamin A is stored in the liver in animals and humans, frequent consumption of liver can be toxic. Both preformed vitamin A and the carotenoids are bound to proteins in food. To be absorbed, they must be released from the protein by pepsin in the stomach. In the small intestine, the released retinol and carotenoids combine with bile acids and other fat-soluble food components to form micelles, which facilitate their diffusion into the mucosal cells. Once inside the mucosal cells, much of the beta-carotene is converted to retinal. From here, vitamin A follows the fat-soluble pathway for absorption. To move from the kidney stores to the tissues, retinol must be bound to retinol-binding protein, RBP, for transportation. Remember that the different forms of vitamin A have different functions. Retinal is the form needed for vision. Retinal combines with the protein opsin to form the visual pigment rhodopsin. Rhodopsin is found in the rods and cones of the eye and transforms the energy from light into a nerve impulse that is sent to the brain. This nerve impulse allows us to see. Night blindness is one of the first detectable signs of vitamin A deficiency and permits early diagnosis. Night blindness is a slow recovery of vision after flashes of bright light at night, or an inability to see in dim light caused by a delay in the regeneration of rhodopsin. From what you know so far about vitamin A, explain why people say eating carrots helps you see in the dark. The answer is beta-carotene is converted to retinal, which is the form of vitamin A needed for vision. Retinoic acid is the form of vitamin A that functions in gene expression. Vitamin A is said to turn on gene expression. This slide highlights this process. So let's start at the beginning here. Step 1. Retinoic acid enters the nucleus and binds to a retinoic acid receptor protein. Step 2. The vitamin protein complex binds to a regulatory region of DNA. Step 3. Transcription of the gene is stimulated, increasing the amount of mRNA made. Step 4. mRNA directs translation, increasing the synthesis of protein coded by this gene. Step 5. The cellular functions and body processes affected by this protein are increased. So what would happen to the amount of protein produced in Step 4 if vitamin A was absent? The answer is decreased. By affecting gene expression, vitamin A can determine what proteins a cell produces and what type of cell a cell will become as it differentiates. Cell differentiation is the process whereby cells change in structure and function to become specialized. Vitamin A's role in cell differentiation is particularly important for the maintenance of epithelial tissue, which is the type of tissue that covers external body surfaces and lines internal cavities and tubes. This leads to vitamin A's role in growth and development, as well as reproduction. Some carotenoids, particularly beta-carotene, can be converted to vitamin A in the intestinal mucosa and liver. Unconverted carotenoids also circulate in the blood and function as antioxidants by protecting cell membranes from damage by free radicals. Please take time to note the antioxidant roles of vitamins C and E in this graphic. When an individual is deficient in vitamin A, keratinization can occur. Keratinization is the accumulation of keratin, the hard, inflexible protein of the hair and nails, in a tissue that is ultimately caused by improper cell differentiation within the epithelial tissue of the eyes. Xerophthalmia is a spectrum of eye conditions resulting from vitamin A deficiency that may lead to blindness. Think about it. How does a deficiency of vitamin A affect immunity? The answer is vitamin A is needed for the differentiation that produces the different types of immune cells. So this impairs the immune function and increases the risk of illness and infection due to defective epithelial tissue barriers. What are the connections? The answer is without fat, vitamin A cannot be absorbed. Protein deficiency can lead to a lesser amount of RBP to be made. Zinc is needed for the transport proteins for the various forms of vitamin A. As mentioned earlier, when a low-fat diet is consumed, the absorption of vitamin A is reduced. This is of great concern in developing countries where individuals consume a high-carbohydrate, low-fat diet. Thus, we see a greater risk of vitamin A deficiency in developing countries. Vitamin A deficiency remains a world health problem today, as it threatens the health, sight, and lives of millions of children in the developing world. To combat this, vitamin A supplementation, fortification of the food, and genetically modifying food to be higher in beta-carotene, as the golden rice pictured here, are strategies. For more information regarding the debate on the success of the golden rice, look on page 377. Today, antibiotics, vaccinations, and a nutritious, varied diet have reduced infant morbidity and mortality. Worldwide, though, infections are still responsible for over half of the deaths of children under age 5 every year, and about 35% of these deaths are associated with malnutrition. The relationship between vitamin A deficiency and death from measles is illustrated by this graph. What is the connection? Back in 1959, the World Health Organization identified that vitamin A deficiency reduces the ability of the immune system to defend itself against measles infection. And the infection itself causes loss of vitamin A that can precipitate acute vitamin A deficiency and blindness. As there are several forms of vitamin A, the DRIs are listed as retinol activity equivalents, RAE. This graphic illustrates how the conversion works. How does the vitamin A in these meals compare to the RDA? The answer is poorly. If the meal from McDonald's is chosen, how much more vitamin A does he need to get from his other meals? The answer is 100 minus 6.2 equals 93.8% daily value. What would be better choices at McDonald's or KFC regarding vitamin A consumption? Toxicity is more commonly caused by overconsumption of preformed vitamin A in animal products, fortified food, and supplements. Children are more susceptible to toxicity. Carotenoids are not toxic because their absorption from the diet decreases at high doses, and once in the body, their conversion to retinoids is limited. Too much vitamin A weakens bones, acts as a teratogenic substance to fetuses before 7 weeks gestation, and it does not cure acne. It can also lead to birth defects and growth defects. Hyperkeratinemia can lead to the yellowing of skin due to the overabundance of carotenoids in the body. This discoloring of the skin will disappear when the individual lessens his consumption of beta-carotene, whether from food sources or unbalanced supplements. To end our discussion of vitamin A, what is your final answer? Which transports preformed vitamin A from liver stores to tissues? Retinol binding protein is the answer.